Hello everyone, my name is P.Tech, working as assistant professor in Thyristor Start Engineering College. Welcome to my channel. My channel name is Accelerate Your Research. This video I will explain power quality and facts subject. Okay. First I will show my previous classes related to power quality and facts subject. This is power quality and facts subject. These all previous videos related to power quality and facts subject. Okay. Now I will show first syllabus. Okay, this is power quality and facts subject. This is R18 JNTH syllabus. Okay, this video I will explain fourth chapter, static series compensators. Okay, in my last class I explained objectives of series compensator and variable impedance type series compensators and TCSC Thyristor-Controlled series capacitor. Now I will explain TSSC. Now, last class I explained TSSC. Now, this class I will explain TCSC, Thyristor-Controlled switched capacitor. Last class I explained TSSC. Okay. Variable impedance type series compensators classified into mainly three types. One is GTO, Thyristor-Controlled series capacitor. Second one, TSSC, Thyristor switched series capacitor, TSSC. Next, TCSC, Thyristor-Controlled series capacitor. This class I will explain TCSC, Thyristor-Controlled series capacitor. This is Thyristor switched series capacitor. In this Thyristor switched series capacitor, this is uncontrolled device. Okay, this class I will explain Thyristor-Controlled series capacitor, TCSC. This is circuit diagram of TCSC. In this TCSC, this inductor, these two thyristors are similar like thyristor capacitor, TCR, Thyristor-Controlled reactor. Okay. Third chapter, Thyristor-Controlled reactor. Thyristor-Controlled reactor connected one anti-parallel capacitor. First, I will explain components in circuit diagram. This is the inductor. These two are two anti-parallel thyristors like AC/DC. This is capacitor. This I is the current flowing in transmission line. This is L in inductance in transmission line. This is capacitance in transmission line. This is IL of alpha is current in this inductor. Okay, alpha is the delay angle, firing angle. This VC of alpha. VC is the capacitor voltage across the capacitor. This IC of alpha is called I plus I alpha. IC of alpha means current flowing in this transmission line through capacitor. This IC is equal to current entering in transmission line plus IL of alpha. This is the total diagram of TCSC. These are the effective value of reactance in transmission line. This is the XTCSC. XTCSC means Thyristor-Controlled series capacitor of alpha. These two like a parallel resonance circuit. XC into XL of alpha divided by XL of alpha minus XC, like two resistors. If two resistors connected a parallel, R1 into R2 by R1 plus R2. Like similar manner here also, XTSC of alpha is equal XC. Here XC means reactance in across capacitor. Next here XL of alpha means reactance in inductor divided by XL of alpha minus XC. Okay, here XL of alpha is equal formula XL of alpha is equal XL pi by pi minus 2 pi minus 2 pi 2 alpha minus sin alpha. This XL it varies from 0 to 90 degrees. This alpha varies from 0 to 90 degrees. Here XL of alpha is less than XL is less than XL of alpha. XL of alpha is less than infinity. This is the circuit diagram of TCSC. Okay, this is a very simple diagram. In practical, this type of converters, many number of converters connected in series. Okay, multiple TCS is connected in series like this. Okay, this is single. This is the four number of TCS is connected in series. Like similar manner, this TCS is also connected in series. Okay, this is the impedance and delay angle of characteristics of TCSC, Thyristor-Controlled series capacitor. Here, controlling means these two thyristors controlling total this impedance in circuit. That's why here controlling series capacitance. Series capacitance are series compensator. Compensator also. Okay, some books have compensator. In the circuit, first this y-axis is xc of alpha. This x-axis is alpha. In this x-axis, this pi by t is 90 degrees. Here alpha L limb, next alpha R, next alpha C limb. Here total three regions. One is the inductive region, second is the capacitive region, third one is this prohibited region. In this region is very danger. In this region, XL is equal to XC. XL of alpha is equal to XC. In this region, the impedance value is 0. Okay, when resonance frequency or resonance condition, XL is equal to XC. The impedance in the transmission, impedance in the circuit is 0. Only a resistance present, resistor is presented. Okay, here the operating region is prohibited here. Okay, next here the alpha value here 0 to 90. Okay, up to here alpha L limb here 0 to 30 degrees, nearly 30 degrees. Here this 30 to 60 degrees, this region. Okay, next this 60 to 90 degrees region is the capacitive region. When alpha value increases from 0 to 30 degrees, okay, the impedance in the impedance is here slightly increasing. Okay, the inductive impedance here increasing. Next, the alpha value we will not vary from this region. After here nearly 60 to 90 degrees, we will vary the alpha value. When we are increasing alpha value here 60 to 90, okay, if you have 90 degrees, the capacitor induct the impedance here like this. Okay, when we will decrease alpha value, the graph decreasing like this. Okay, increasing negative side. When we will increase alpha value, here the inductive impedance increasing from 0 to, okay, here like this. These two regions is the inductive region. This is the capacitive region. The inductive impedance increasing like this. The capacitive impedance increasing this negative side. Okay, this is the resonance condition. XL is equal to XC. These are the characteristics. This is the circuit diagram, TCSC. This is the characteristics of impedance versus delay angle characteristics of TCSC. Next, this is the third Thyristor-Controlled series capacitor. When will switch open, conditions. When switch close time, these waveforms. When switch open, that time this waveform. Here I have total three ABC. This is the first waveform. I will explain first waveform. This is the current flowing in transmission line. This is the I. I is the current flowing in transmission line. Okay, this is the when switch closing here, the current, the voltage lags by 90 degrees. When current flowing in the transmission line, the VC0. VC0 means the voltage across capacitor lags by 90 degrees. This is the alpha firing angle. Okay, this is the alpha. This is the voltage and current waveforms. Current voltage lags by 90 degrees. When switch close condition, this is the waveform. When switch open, the here the current, this is the current waveform. When we will open switch, the voltage it increases suddenly Okay, suddenly Vc of alpha. When we will change alpha value, okay, here when we will change alpha value, the voltage it increases suddenly. Okay, this is the actual voltage. When open time, switch open time, the voltage is increasing suddenly. Okay, Vc of alpha. That time current here, IL of alpha is a negative peak. Okay, current with direction is reverse. Okay, inductor current it goes reverse. IL of alpha. Okay, this is the TCSC. The main difference between TCSC and main difference between TSSC and TCSC in thyristor switched series capacitor, we will not control the impedance value. In thyristor controlled series capacitor, we will control capacitance value. We will vary from 0 to infinity. We will vary impedance it 0 to infinity value up to. Okay, the main difference is that. Okay, thank you for watching this.